So the material I'm going to present to you now, we've been working on it for some years, and actually these slides were created for a meeting which was held in 2006, which was a meeting for, it was a meeting called Ontology for the Intelligence Community, which was held in an undisclosed location in Washington. But as you will see, the ideas are very, very relevant to what you're concerned about. At least I hope you'll see that. So there is an issue. How do we keep track of data? How do we keep track of the things which data are about? For instance, samples, or the processes in which data is created. For instance, measurement processes, or isolation processes, or assays of different sorts. Now, one strategy is that we give IDs to all of those things. And so there is a movement, which I'm sure you're all very familiar with, called the Life Science Identifiers Movement, LSID. And the mission statement goes something like this. Life science identifiers are a way to name and locate pieces of information on the web. Essentially, an LSID is a unique identifier for some data, and the LSID protocol specifies a standard way to locate the data. And the standard way is similar to the standard way that we would involve, which would involve the use of URIs. On the internet, it's just that the LSIDs are maybe alphanumeric strings, which are designed to be unique. Now, I think I agree with this strategy, but the strategy I'm going to recommend is, I think, more suited to your purposes, and it's different from this in one big way. Namely, it's not just a strategy for giving IDs to data, it's a strategy for giving ideas to anything, including samples, including organisms, including artifacts from long ago. So it's a strategy for giving unique IDs to any kind of entity. And we were talking this morning about types, and you could give IDs to types. In fact, we do give IDs to types. All the terms in all the ontologies that the Obo Foundry develops have unique IDs for each preferred term within the ontology. But now we're going to be talking about giving IDs to instances of types. Now, if we think about that distinction between instances or particulars on the one hand and types or universals on the other hand, then we can distinguish two kinds of artifacts which represent these things. On the one hand, there are artifacts which are primarily about particulars, which would be, for instance, a factory inventory, which gives you a long list of all the items in the factory. Or a database of the sort which I will be describing, a reference tracking database, which is primarily about particulars. And then we have representational artifacts which are primarily about universals, and scientific theories, scientific textbooks, scientific journal articles are primarily about types. When you do science, you're not interested in conveying information about any particular instance. You're interested in conveying information about all instances of a particular type. And then ontologies and terminologies are, again, primarily about universals or types. And these would be non-formalized and these would be formalized, broadly speaking. So now we're going to be interested in these things. So we're going to take a realist view of the world, and so we actually see the world as being such that there are particulars and universals in it. So there may be other kinds of entities, but there are certainly particulars, and it's the one basic assumption of the ontology approach that I'm defending, that there are also universals in reality. And then there are occurrence and continuance. There may be third things, but there are at least occurrence and continuance. And some some continuants are dependent, some are independent. And then we talked this morning about different kinds of relations between particulars and universals, relations between particulars and relations such as are used by ontologies between universals and universals. So that's just repeating some of what we said in the morning. So if we let this thing rip slowly. Slow rip. So this is an instance of the type aeroplane. This is actually, this is wrong. This is an old slide. I'm not a philosopher anymore. And this is an instance of the type airport. And then, hang on, let me, so these are occurrence, and these are continuants which may participate in this occurrence. So this aeroplane with this passenger lands on this airport. So 3 continuants which participate in one particular process of flying. And then if he ever meets him, then we would have a meeting, 2 participants with one occurrent, which is a meeting. And now, this particular is an instance of the universal child for a certain period of time, and then an instance of the universal adult, and there will be a time when this particular is not anymore. And similarly, there was a time when this particular was an instance of the type philosopher. And similarly with... Now, these ways of representing, namely JFK and Enola Gay and George Bush, are not good ways of representing, if we want to be precise, because there are several things called JFK. There are several things called Barry Smith. There are several things called George Bush. And there are several things called Enola Gay. I understand this is a rock band. So we want adequate representational units, which means we want unique IDs. So I assume everyone agrees with this particular notion. And so I want to propose a solution which is in the same family as the LSID family, but I think it's more appropriate to our concerns because it is a system of IDs, not just for data, but for entities in the world. So the purpose of this referent tracking idea is to make explicit reference to the concrete individual entities relevant to the accurate description of a scene or of a scenario like the measurement scenario that we just described. So it's closely connected with a strategy embraced by Gary Larson. So that should clear up a few things around here. So we make sure that everything is properly labeled. Ideally, we would give a barcode to every molecule, but that would take too long. And in fact, this is what we want. We want to give numbers to everything. Only then will we have genuine clarity.
A satanic thought.
And we call these numbers UIs, instance unique identifiers. So more precisely, we want to give unique identifiers to all of those things which are of concern. Now, this work was devised originally for hospitals. So when you're developing an electronic medical record for patients, you use coding systems. So you might use the word fracture, for instance, to refer to a fracture in a patient. Or you might use the word pimple. Or you might use the word lesion. And the coding systems work pretty well, but they don't give you a unique ID for the fracture or the pimple or the lesion or the tumor or the hospital where the patient got a nasty viral disease. Rather, you just have a code for hospital or a code for fracture. So if you come back 3 years later and you have the same fracture, then your medical record will say fracture. Earlier on it will say fracture, but the doctor will not know from the record whether it's the same fracture or a different fracture. And if it's in the very same place, and if it's the same kind of fracture, then there is no way of knowing from the medical record. Now, on our strategy, all of those things would get unique IDs. And then you would use those unique IDs in order to disambiguate fracture as it appears at one place in the medical record from fracture as it appears in another place. Existing medical records do that disambiguation for people by giving them unique IDs. They do it for buildings, They do it for X-rays, but they don't do it for fractures or tumors or diseases or any of the other things that exist in the medical coding systems. What they do is the codes for diseases are more precisely diagnostic codes. And what this may mean is that the medical record has 4 diagnostic codes, but there's only one disease. And it's impossible to tell from the existing medical record how many diseases the patient has because you don't know whether the diagnoses relate to the same disease or to multiple diseases. All right, so the essentials of the idea are to have a way of generating universally unique IDs. Then you have to decide which particulars should receive one of these UEs. And when you're interviewing a patient, then it's pretty clear which items are important enough that they should get unique IDs. Now, the important thing is that the UEs should track. So if this patient had a pimple 3 weeks ago, then you want to use the same UE today as you used 3 weeks ago, so that you can then track the UE across the 3-week interval. And so before you can assign a UE, you have to decide whether or not that particular has already been assigned a UE, because each particular should receive maximally 1 UE. Then we need to find out how we can use these UEs to make statements, and then we need to find out how we can determine the truth values of these statements. And then, most importantly, perhaps, we need to find ways of correcting the errors in the assignments of UEs. Because sometimes, for instance, we will assign a new UE to an item which has already received a UE earlier on. And then we need to correct the original UE assignment. Now, with regard to the first item on the list, there is already an ISO standard for the generation of unique IDs. And so these are 120-bit identifiers which can be guaranteed to be globally unique with a vanishingly high probability of a doubling without any kind of central management or certification. So the idea is that each group which is identifying samples, processing these samples, making statements about these samples, will use globally unique identifiers generated by this mechanism with random numbers, basically. And then those globally unique identifiers will be the identifiers for those samples forevermore. So sometimes they'll be incorporated into barcodes, sometimes they'll be incorporated into labels on boxes, but they will be the UEs for those samples.
Can you clarify the very last note on that slide? But U says UE requires that there is no central management or certification required. Can you clarify that?
Previous slide.
That slide right there.
Yeah.
This one here? Okay.
So
The use of the UEs requires the uniqueness, it doesn't require central management, right? The verb require refers to uniqueness, not to central management.
So actually, the use of the UE will in some cases require central management. And I'll give you an example. So my co-author on this, I have to apologize, is Flemish. And so if the English is bad, then we blame him.
Whether or not he wrote it.
So there will, in some cases, be a non-local management required. So because patients move from one hospital to another, and when you have patients who do that, then you have to have a strategy whereby the doctor in the new hospital can call the doctor in the old hospital to check whether a given UE has already been assigned. So that degree of central management is required. And I guess within your sample collecting world, there is something similar.
But in the medical environment, most local clinics tend to come up with IDs that are only locally unique. They've got their own patient identifiers.
Yeah, and that is something that this whole strategy is designed to counteract, this tendency to create new local IDs, including local IDs for patients.
Right.
So there is an increasing problem which is caused by the fact that more and more hospitals and doctors have electronic health records, but more and more are the incompatibilities between the coding systems used by these electronic health records causing problems. And our strategy is that some of those problems can be solved by increasing the degree to which unique IDs are being used to refer to the items described in the record.
Just for the record, there actually are, so there's two different kinds of management we're talking about. One is the generation of the strings,
Yeah.
strings which is done by computers. The second is how they're decorated with metadata according to practices. And the former actually does rely on two human-maintained registries that we don't usually think about. One of them is IEEE maintains a registry of hardware vendors, and I don't know what their policies are. I've looked, but I don't know if they reassign things to vendors. Another registry is the vendor itself, manufacturing all these Ethernet boards and assigning a unique MAC address to each one, apparently, but what we don't know, each vendor is going to have their own practices, and any human process may actually come up with mistakes. So I would be very surprised if there weren't, MAC addresses that have been reused for in different settings. But we just happen to come across them.
So would you be surprised if there was a MAC address which had been used by accident as a credit card number somewhere else, for instance?
No, but that's a whole different domain.
Good. Okay.
The
so
same string
I would be
generates
very,
writing it down.
I would be very unhappy if I thought that MAC addresses could be reused, even by accident.
Yeah, I'd be unhappy too. But I'm just saying, there are two human registries at work, and we don't even
Yes.
know their policies.
So my understanding is that there are many human registries like this, some of which are local. The FedEx parcel tracking IDs, for instance, is one example. But all the barcodes used by supermarkets, used by vendors of various sorts, manufacturers, are in fact unique IDs, because the code that you see, the numbers, is only the last string. And each manufacturer and each supermarket, each vendor, is given by the central barcode organization in Geneva. I think it's a 96-digit long string, which is the prefix to the final 12 digits or whatever it is in the barcode. And I guess that practically all big manufacturing organizations use those barcode IDs in a way which is designed to avoid. It creates a kind of invisible centralized management of barcodes.
I'm not quite sure how they assign their MAC codes, their MAC addresses.
I don't know how they do MAC addresses, but that would be
the
separate.
algorithmic
Yeah.
integrity of the UID, which is, I think it's a great thing, and for all the reasons you state, it's just not quite as strong as.
Yes, so I have a feeling that the MAC addresses are probably too short for the ISO standard, but anyway. So there are gigantic numbers of unique IDs already being issued, and I think not every barcode, but nearly every barcode conforms to a single standard in this respect. Now, so I'm not getting any strong negative feelings. So the idea of using a randomly generated unique ID for biological samples, is this already being practiced? Is it absurd?
No, it's in practice.
It's being practiced.
But it's in practice in many places.
Good, good. So my idea is that it should be in practice in every place, and that many of the worries that people have would be addressed, at least in part, if this could be relied upon to be in practice. Because then we can always re-identify what sample we're referring to by referring to the unique ID which is associated with the sample when the sample is first taken.
That might be true for recent samples, for new samples, but historical samples is a big problem.
So
We shouldn't exclude historical samples by demanding to assign them unique identifiers.
So-
contains a lot of historical samples.
We can take databases and that have a lot of historical data, and so there's the data that's very operational. Now we'll go and post hoc assign a whole bunch of unique IDs
Yeah,
to
that
them.
would
And
be-
then the problem that we have is, like you said, has this patient already seen
Yes,
a doctor?
good.
And we have this problem of taking human usable data that we understand the bits and pieces of and trying to identify this thing as it's in the same anywhere else.
So in real world biodiversity data, we do have a set of cases that preclude this idea of an original identifier on the original sample because, you know, there's a billion of them that it's just not practical that you're going to do that. But what we do have is metadata that's been captured off of those, and that's where the LSIDs come in and sort of being applied to data because the mindset is that it's data that's been captured off all these in a large proportion historical samples.
Okay, so if this really is a problem, namely knowing what samples particular metadata and statements are associated with, then I would conceivably, I would suggest some kind of a pilot experiment where you take some large data resource about old samples where the samples do not have IDs, and then retrospectively generate unique IDs for those samples and see what the problems are which arise.
That's what we're doing with the data. We're doing it with the data.
Okay, good. But you're doing it with, but then what would be the objection to taking the further step and awarding a unique ID to the sample itself?
Resources. To actually do that, to actually put a label.
I see. So in other words,
reality,
yeah, good. So you can label the data easily and cheaply, but you can't label the sample because the glue and the paper would be too expensive.
Or there's a large number of them.
Millions is the number.
Did I understand you right? When labeling the data, you have to be sure that this is not a copy of the data, which is already labeled otherwise.
Well, then we have we have the problem of building the same as relationships between two identifiers that are assigned in parallel without knowledge that they're referring to the same thing.
And in the cases where you don't know what you don't know, then we can't establish relations when we don't know the relations. So in some sense, we use this data to then back into or infer relations.
Yeah. So in some cases, you can infer reliably that this data and this data are about the same sample. If you use LSIDs, you would keep the LSID for this data, the LSID for that data. How then would you express that they are about the same sample?
Good question. That's one of our...
So, and I guess that's where I would claim to have some sort of an answer. You would have a UE for the sample, which would be inferred.
Truthfully, what we have to wind up with is I don't know what you call it, synonyms. We have to be able to say, we have now discovered that LSID1, LSID2, and LSID3 are actually associated with duplicates of the same thing. We need to record for history now, they are interchangeable. All three are the same.
And then I would say that the neat way of doing that is to generate a UE for what they're about, and then you can treat them in just the same way that you treat other data where you do have a unique ID for the sample.
So you could create a fourth ID that refers to the others.
Exactly. And the disadvantage of that would be that if you found a fifth body of data which was also about the same thing, then it would be easy just to add a link where, anyway.
That's right.
So we thought,
Definitely
we haven't thought about the idea of retrospective assignment of IDs very much, but we have thought about the idea, the problems which arise if you discover that three, let me go through the cases. One item has been given two IDs independently, and then we merge them. That's easy. But what happens if one item has been given, what happens if two items have been given one ID? And then you have a whole series of statements about that one ID, which were held to be about one item. Then you have to split the statements and assign some to one and some to the other. And that can only be done by manual checking. And then the other thing that we have is reserving IDs. So we know that an X-ray will be taken tomorrow, and we want to say something about that X-ray today. For instance, that it will happen at 3 p.m. So we assign an ID for an entity, namely the X-ray, which hasn't yet happened or been created. And then the ID will become official only tomorrow, but we can talk about it already today. Over there?
I was just wondering when you were responding to my question about the three IDs refer to the same thing and creating a fourth unique ID. So what are the advantages of doing that against using L same as to equate to three IDs?
So there are many times in which you're going to want to say something about the thing which those three data are about. And this will give you an easy way of doing it. So you have three bodies of data. You discover that they're all about the same thing. You want to say this thing was an arthropod. So now, under my proposal, you would say item number 13456 was an arthropod. What would you say under your view? You'd have to have a complicated quantificational statement. That
No, I thought that in Chuck's example there already existed three IDs.
no, there are three IDs for three bodies of data.
All right, I thought you had three IDs for three.
Yeah.
Or for one.
Oh, no,
thing.
that would be another story. So, and there you would need to collapse them.
In this incredibly complicated world of biodiversity that we all try to contend with, I mean, we probably have every combination that you just described plus a few others. What in this particular case I was referring to, I come from the world of plants, so it's a very common practice that they pull, three branches off the same plant. And then they mount each one of those three branches on three sheets. And each one of those three branches is of the same plant, not just the species, but the plant itself. And then they get distributed and then get to three different institutions, and then each institution can put a different ID on it. And that's how they wind up being three IDs for the same.
Okay, so I would say you give an ID to the plant, and you give an ID to each branch. You give an ID to each piece of paper with the branch mounted. You give an... What?
I would say, kill the lawyers, kill the botanists. When I was at NSF administering these computational programs in Museum Court, this was the big bugaboo. We have herbaria full of specimens of the same individual plant with different identifications.
Yeah, so then...
And then different annotations, which they
Good, but then part of that problem would be solved if you gave an ID both to the specimens and to the organism from which the specimens are derived. Yes?
But the curator would consider that three separate specimens. Never mind they came from the same plant. There's something different about all three of those.
Well, if they were all at the same institution, that one curator would. But
But even if they distribute them, they can, then that becomes three instances of the same collecting event, but three separate specimens.
But the point here is that they get different identifiers because there are three different
Correct.
places.
So I would want an ID for the collecting events. Each collecting event should have an ID.
And what is a collecting event? Cutting three branches off a tree, or is that one event that you did cut three branches, or is that three events?
I would think three, but who am I to say? I never chopped a tree down in my life.
So we've been working on that a little bit at Natural History and working on our projects with one of the botany curators, and he's doing a recording of mostly tropical tree species on CTFS plots, and CTFS sites are these sites run by Harvard, and they have researchers out there collecting and doing censuses of trees and ecological studies. So this is a controlled environment. So you have trees where they've gone out and they've counted all the trees. They've put tags on all the trees. So every tree has a number. So what the scientists at these plots will do will then collect tree samples for us. So we want
Tree samples or tree part samples?
samples from the individual. So we've
Okay,
had
so-
this discussion before in our small meetings because I'm building the back end of the database. And they're talking species level and, you know, we have numbers on individuals. So with individuals, you take samples of individuals. So the unique IDs, like the tree tag number, the sample that was taken. So 4 samples from each individual, 1, 2, 3, 4. And then from each of those samples, we take tissue that becomes DNA. So each one of those 4 samples has a lifespan, has a life to it, cradle to grave to trace file or whatever.
So just let me make sure I'm keeping count. There's the tree, which has a tag number, 4 samples, each of which has its own ID, and then 4 DNA, or multiple DNA.
Multiple children off each of those samples.
And would they each DNA sample have its own ID?
Yeah.
Good. Okay. So then,
So there are ways to do that, but in the wild, when you're not tagging trees, and I think the problem comes in with botany, where there are multiple, you take multiple specimens, sheets off different individuals over time. Those individuals are double counted in terms. If you
which
want
is why we need to give an ID for the cutting act, because then that can be dated. So you have 5 samples from the same tree, 5 acts of taking those samples, and each act in principle could have a date associated with it. And if you don't give the act of cutting an ID, then you have nowhere to put the date, because you can't put it to the sample because the life of the sample is longer.
It's just the same as your example of fracture, because you can take an X-ray of fracture, but you can't actually physically put a label on somebody's fracture and say, give it an ID. Just
Not
the same
yet.
as you can't do like the other tree. So you're just having a...
I'm not sure about the advantage of giving the ID to the act of collecting the sample versus assigning an annotation to that sample saying the sample was collected on that date.
Oh, I have one. We're looking at that too in Urbis, is that if you have these individual samples all from the same specimen and the same collecting date, and you give it to a bunch of different museums, maybe one museum has far better metadata than another, but they have no way of connecting their data to the same specimen that was from the same collecting event over here in this museum who has awesome metadata. But if you do have a way of saying this was from the same collecting event, then they can collaborate and have the same information.
But then you'd have to have one collecting event for all 4 samples instead of
Right.
4 collecting events. which
Right.
is-
Well, if it was... So the idea is that memory space is increasingly cheap. Numbers are free. Even very long numbers don't cost anything. And so you should, if you think that you might need it, then you should keep it when it comes to an ID. So if you think you might need to keep track of the actual collecting event, then give it a number. If no one ever uses the number, you haven't lost anything. Now, why might you need it? Well, it may be that there are certain important data about the cutting event which you can't assign to anything if the cutting event is replaced by an annotation on the sample ID.
One of the serious obstacles that we have, challenges in this domain, is the fact that we are lacking, we're missing, it's just not there. So there's the idealism of how great it would be if it were all fully populated with all of these facts. But the truth is it's sparsely populated, and it is within that sparsely populated reality that we have to fit a method, a data structuring approach that will work. In the absence, or in the sparsity of, here I do have the UI, there I don't have the UI, over here I have this, and over there I don't, and now I have to build an ontology or a world that I can do my analyses against in the reality of those missing points in the structure. So that's, that's what we're all contend with, is how do we do this with what we have, and then maybe we use our process or our automation to try to infer some of those missing.
Okay, we're always going to have to infer some of it, but when we're talking about what we tell people to do next, so was I not right in thinking that there are people from the Barcode of Life Marine? So what do you collect in the way of data when you are barcoding marine samples? How does it look?
We're trying obviously to collect the specimen metadata. So
And you collect also the time at which the specimen is collected and the location? And do you...
and the person who collected it and the person who identified it, and then we give a unique process ID to that sample in our database.
So the process ID would mean the process of collecting the sample?
That's just when it comes in for barcoding. Right? There's a collection ID, presumably, of that particular material voucher specimen in its host institution. So that would be something like ROM Ichthyology 10297 is the institution, collection, and the catalog number of that voucher specimen. That's the identification number for that collection object in that institution. We also assign a process ID to that tissue sample that arrives for barcoding that's unique to our database so that we can refer to that uniquely within our system.
And why do you call it process ID?
I don't know specifically why the database architect defined process ID, but just as, I guess, an act of sort of thinking about it's being barcoded, right? There's a process that's happening in that tissue.
Right.
It's our core facility. And so it's tracking that particular specimen and the generation of the sequence data.
Okay, so let me tell you what's going on in the back of my mind. So you have the process of barcoding, which is some kind of assay, some kind of... Yep. Now, supposing you have one lab which is doing it in one way, and another lab which is doing it in another way, and then you want to compare the processes and see which leads to more reliable something. Then you would need to have data about those processes. And you're not collecting that data, I guess. Or you are, but you're collecting it as metadata within the...
Yeah, because we're also collecting, so within that, so there's only a partial description, of course. Then you have the sequence that's an assembly that's based on raw electropherogram trace data. And those raw electropherogram traces are generated at a lab. So there can be multiple labs around the planet generating that data. The electropherogram trace data that's linked to the specimen metadata. It's also linked to the contig assembly. You can have different centers of origin for where the trace is generated, just the same way you can have a different center of archival for the collected specimen.
Good. You think you're doing it right?
No.
Why do you think you're not doing it right?
Well, there are a number of our data elements right now that I don't think we've really atomized and built structured vocabularies for. We've still got an awful lot of fields that are just kind of free text.
Okay,
and then we're waiting to see if there's enough population of these fields with enough standard terms that you can distill something meaningful out of them. So our database architect takes the view on some of this. We had this discussion a little bit earlier today, but the idea that database theorists would say, let's have a unique field and define vocabularies for everything, and we can proliferate this out to the point that no normal biologist can ever figure out how to properly use the system. So our database architect takes the attitude of, let's keep it simple so that it's fumbleware, and see how people use it, and then we'll sort of adopt the structured vocabulary based on common usage. And I think you can argue for both ways. But, so I think we've got part of it right.
Yeah, so I'm arguing for the other way.
So here's the problem with, okay, so I can claim to be both from the computer science side as well as the biology side of it. And I don't want to go into why, but, and so I'm in a position to criticize both types of folks. So here's my criticism at the database folks, which I was formerly. Yeah, you have a database structure and a schema. The problem is that the schema developer is not aware of natural processes that you need to capture in order to fully ascertain what's happening in nature, right? So, for example, if I were to go onto the field, right? I'm 5'7", all right, roughly, and so if I were to collect leaf samples, I'll be collecting it kind of roughly around my height. Although, yeah, depending on the protocol that you use, the protocol that you go onto the field might say you must collect your samples at 6 foot. If the protocol is, and if the protocol process, if the protocol is that detailed, then yeah, then you can have a very simple schema, and you capture the protocol in some metadata that you say that sample was captured at that height. But the problem is that not every database schema developer would know that detail will matter in the field, because that's what's called as bias, right? Sampling bias. I'm this height, I'm going to sample from this. But then what happens in the field is that your museum has samples collected at 5'7". Another museum who hires like 6 foot tall basketball players will have their samples collected at 6 foot 3 inches. But that difference in height is a systematic bias, and so this is a ridiculous example. Imagine that it's a spider species which only lives at 5'7", and there's another different species which is a niche-based thing, right? So, which one I'm now going to put on by biologists. So if you're looking at niche-based studies, right, you're going to look at one museum and you say, well, there's no spider X there, but there's a spider X, spider Y where it's collected at 6'3". But if you don't capture the sampling event to that level of detail, you're going to come up with the wrong conclusion. And so like, this is a very long way of going around to addressing what you raised about database schema developers. So leaving that in the hands of the database schema developer, I think, has very significant drawbacks. I'm saying that even my organization, Neon, we suffer the same problem too. I mean, we have our schemas being developed right now, but sometimes, the schemas need to be developed with a lot of scientific input about systematic biases that can happen in the field. So,
good. So the general moral from this morning is that some of you working in this area need to agree that you're going to develop collaborative standards for describing what you're doing and what you're keeping and how you're keeping it, and then work on those collaboratively, find out what is needed to be collected, and then try and show the benefits which that collaborative, scientifically adequate set of standards are, so that other people with less forward-thinking data designers will see the need to do it that way.
We just have finished a project, a European project, which was called EBON, where they wanted to have a completely standardized protocol for certain species investigations. And they really sat down and wrote down the protocol, really specifically fine, nice, and so on. When working on the data, they discovered that the interpretation of this protocol was deferred from one institute to the other. So you never can avoid, you can't achieve a protocol which is so clear that you might not have any misinterpretation. What I want to say now is that you can't avoid to somehow record what you really have done.
So I agree with the last thing you said, but I see one possible solution to the problem that you said before that, which is that if different institutions are implementing this protocol differently, then you identify those differences and see how they matter, and you modify the protocol so that the possible differences are warned against, so that people will, at least in those dimensions, do the same thing. Exactly the same issue arises with electronic health records. So Obamacare is based in part on the idea that you can get benefits from guideline-based medicine, and that you establish the guidelines by having many different hospitals perform medicine in accordance with the guidelines, and you show that the benefits are greater than in those hospitals which don't perform in accordance with the guidelines. The problem is that the medical records, even the very same coding systems, are implemented differently in different hospitals, so you can't make the comparisons. But if you have a small group of like-minded investigators who are concerned to find out how to write the protocols for implementing the codes so that they are implemented consistently, then you will indeed have data that you can use.
If you would propose a cyclic process for implementing such a protocol, I would agree. But I'm not so sure if this cyclic process is ever ending. It just can get better and better and
Well,
better.
science is never ending.
Yeah.
So does that mean we don't do science?
Yeah.
Ontology is never ending.
Barry, before you go on,
Yeah.
could you repeat what the substance of what you were trying to get here on this slide about when IDs are assigned?
Yes, so again, I'll talk about the medical case. So the ID would be assigned in the clinic. The clinician sees the patient. He notices that the patient has a rash on his cheek, reddening on his head, and complains of a headache. And so he will write down complains of headache, rash on cheek, reddening on head, and the system, the coding system that he's using will immediately generate codes, the general codes, and UIs for those three things. And then if there is in the patient record an earlier rash, the system will flag a question. Is this the same rash as the last time you saw him 3 weeks ago, let's say? And if the doctor says yes, then the new code will be removed and the old code will be substituted. So that's roughly the idea. Now, I would assume that when the people, is it the Barcode of Life people who collect samples from the sea?
Sounds like the metagenomics.
So the metagenomics sample collecting use GPS devices in order to identify where the sample was collected. Well, those GPS devices would be equipped with UI generating APIs, and the data then would contain an API for the sample, an API for the event of collecting, and those two APIs would be associated with GPS coordinates and a date, and a UI for the person who was responsible for making the collecting event. And here, I guess there's no need for any kind of checking, because you can't take the same sample out of the ocean twice. And now, so the UI can be assigned by a person, or it can be assigned by a device. So that's what this is, or by an organization. But it should be assigned at the first point where the entity which gets the UI becomes relevant. Now, not every entity is ever relevant. There is a certain amount of care needed, so you may need to predict what might be relevant. And as I say, numbers don't cost anything, so it's reasonable to encourage people to err on the side of awarding UIs generously rather than scrimping. Yeah.
I don't want to go down a rabbit hole on this one, but if you have like a good packaged answer for this, great. If not,
All right.
talk later. So when I first started doing database stuff, I was working in biotech and drug safety, and so we were using these medical coding dictionaries. And when we would get a patient report of injections, so two really benign things would be injection site reaction and injection site bruising. They were really ambiguous, and so sometimes things would be labeled as a reaction, and some things were labeled as a bruise. But when we looked, every quarter we had to aggregate the data. And when you needed to roll those things up, I just didn't feel like the numbers were quite right, because we would always kind of equivocate on whether it was a bruise or a reaction. So within that medical coding dictionary arena, when you do have two things that are the same, what's the process, or that are similar, what is the process of kind of figuring
So
out.
in that particular case, I would say that a bruise indicates a reaction. And so if you code for bruise and you code for reaction, then you're double coding. The reason why your question is interesting for me is because a bruise is a continuant or a reaction is an occurrent. And the difference, of course, is that the reaction occurs and then where a bruise continues.
Sure, and that's probably why the nurses would be confused.
Yeah,
Because
right.
to them it meant something different,
Yeah.
but to the, so I guess the issue more in the dictionary, the method
Yeah,
dictionary.
so there should have been a choice just to use reaction, and then you would have avoided the double counting.
So hemorrhage is a continuum.
So there are very many terms in the English language which are used in some contexts for a current and in some contexts for a continuant. So a better example than hemorrhage would be poisoning. So there is the act of poisoning and there is the result of the act of poisoning, both of which are called poisoning. And we get coding errors if we put poisoning in the system. So I first became involved with medical ontology because actually the co-author of this piece is the man in question. He had a company in Belgium which offered translation services to the European Union, to big medical companies, insurance companies. And his translation services were based, as the European Union is big on translation between languages. His translation services were based on a big medical ontology, and each of the languages was mapped to this ontology. And he was reading my work, and he saw how I had been discussing the difference in continuance and occurrence. And when he added that difference into his ontology, the translation effectiveness was suddenly bigger, better. And so he contacted me. He said, I've been following your work, and it really helped. Can you help me more? And we've been working together ever since. Now, with regard to hemorrhage, I imagine it's just the same.
While you're thinking, it seemed to me like the act of bleeding is more verb-like than noun-like. The puddle of blood is noun-like. The fact that when you bleed internally and it stays below the skin means that the puddle of blood under the skin, I guess, is the bruise. So that's what persists. But the act of creating it, which was the hemorrhage, doesn't.
So you see, you do get it. All right, so as we can see from these discussions, the criteria for assigning UEs are different for continuance and for occurrence. Continuance very often survive. Bruises survive for a while. Samples may survive for a long, long time. So the continuant is in front of you. You can see it and you can photograph it, and you can assign a UE to the photograph or the X-ray or whatever it might be. And you can also assign a UE, of course, to the act of you taking the photograph. The occurrent occurs in your presence, and if you're lucky, you can make a video. And the video would then get a UE, and your act of taking the video would get a UE. So you would have four things. The occurrent itself. The video survives because the video is a continuant. And so it sticks around, and you can use the video as a way of...
So these aren't really prescriptive definitions for continuant and occurrent, right? Presumably, things that you don't see could be continuants. I look at a video and I think that's 24 frames a second, 24 photographs. So if you can photograph something more than once, does that mean it's no longer a continuant, it's an occurrent?
No, on the contrary. The fact that you can photograph the same thing on different times is the mark of being a continuant.
That's why your definition number 3.
So none of these are meant to be definitions. None of this. If I'm giving you definitions, I will put D, E, F. Now, another feature of UEs, which make them, this is the reason why UEs need to be alphanumeric strings rather than meaningful, is that you may need to assign a UE even though you don't know what you're assigning a UE to. Now, in your field of samples, you always know, I take it, the kind of sample. You may not know the species, I guess. But you would still be able to assign a UE. In medical diagnosis, very often, you have no idea what you're assigning a UE to. All you know is that there's something wrong. And it may be that tomorrow you discover there are two things wrong. So the UE you assign today, you need to split into two UEs.
Sort of meaningless is needed, which says that, for example, if you take the barcodes for products, then there are collections for certain producers and collections for certain countries and so on. And I think we would also need such collections for certain countries, for certain institutes, things like that.
So the device which generates the UE would have a UE. And to that degree, there would be a certain kind of local identifiability. So I think I agree with you. There's no difference of principle here. But you agree that with this, that it still has to be possible that you assign a UE, even though you don't know what it is that you're assigning the UE to.
In metagenomics, you have that as an example. So you sequence the bacteria in a soil sample, and you assign all the genes to a particular thing. You don't know what that thing is.
Right. Or whether it's just one thing, or three things, or bacterial goop. These are old issues. So to the people on the western side of the Himalaya name the mountain one thing, and the people on the eastern side name the mountain on a different thing, and it may take hundreds of years before they realize that they're naming the same thing. And the same applies to the morning star and the evening star. And then, well, these are criteria for UE assignment. So one criterion is that this is Flemish English again. So what he means here is it's not allowed to assign a UE if the UE has already been assigned. You can't assign the same entity a second UE. And then what this means is that you only assign a UE if it's relevant, if it meets your goals. It has to be relevant to your purposes. Now, if you're engaging in data collection for biodiversity research, I would say that erring on the side of over-generosity in assigning UEs is the right thing to do, because that's your job. But if you're seeing patients, and you have to see multiple patients in every 20-minute period, then you don't have time to assign UEs to everything that you might assign a UE to, and you're restricted by the possibilities offered by your coding system in any case.
So can I ask a question?
Yeah.
How do you know if something has been assigned one or not?
Well, there's no easy solution to that problem.
I mean, it doesn't seem useful. I mean, to have three. I mean, practically speaking, like if we're getting down to very minute pieces of specimens or whatever, and multiple people are looking at the same thing, but I cannot say anything about it unless I know whether or not somebody's already assigned an identifier for it. But if I don't have a way to determine that, then.
So I would say that in this field, actually, you're going to face relatively few problems, providing the culture of assigning UEs is established, because the thing will.
I see a bird flying across.
Good.
I want to say I observed that.
Good.
How do I know if someone's assigned a UE to that or not?
Good. How would that be dealt with under present conditions? So what would you do? Who watches birds?
He creates a record in his field notebook or whatever, however he's recording it, and there's I don't think there's a question. If we adopt this practice, it would get one.
But how would I know?
The question is how many?
Yeah, there's a problem of double counting.
Right. But the problem is you can only have one.
Yeah.
There can only be one.
For which concept?
You wouldn't be assigning it to the bird, it would be assigned to your observation.
Yeah, that would be the safe thing, I think. You assign it to your
What if three
observation.
people observe the same bird?
Well, how does the bird deal with that?
I don't know.
Yeah.
I don't trust these bird data.
So I would say that if there is an obvious problem of double counting or triple counting.
This is fundamental to the scheme.
No, because she already gave the right solution. Here you can lawfully, with good conscience, only assign a UE to the act of observing. Otherwise, it's just a code. Bird, blue, 100 feet high, 20 miles per hour, and then you
don't use this to identify things. It's only for...
No, on the contrary, you should, as far as possible, use it for every damn thing you see. But if you can't follow this rule, then you're not allowed to assign a UE. You could tentatively assign a UE. You could reserve a UE. So if you've got a friend on the other side of the fence who's catching birds and tagging them, then you reserve a UE in case he catches your bird.
If the scheme fundamentally relies on this number 3,
which we should translate into English.
Okay, so if it relies on this, if you do some type of computation based on this, but you can't actually satisfy 3, then the whole thing's broken.
No, on the contrary, you can satisfy it precisely in the... If there is a danger of double counting, you do not assign a UE. That's what 3 means. You only assign a UE where there is a way of checking. Otherwise, you'll get double counting, and then the whole scheme will be broken.
That's what I'm trying to say. Yeah. So double counting breaks the scheme. I think there might be a problem
No,
with the scheme.
because provided people are ensuring that they mitigate double counting, and providing we have strategies for rectifying the consequences of double counting when identified, we'll be okay.
But that's the severest problem. For birds being observed, that might be quite easy, but just think about a fact occurring in the sky, being watched in China and in the United States, till you can go through these observations. You might have a giant amount of obstacles.
So I bet you, although I haven't spoken to them about this, that astronomers have pretty good ID systems for events, because they will want to share data, which they probably do it properly.
Not the UIDs for observations.
And in the future, when we have universal global satellite videoing of the planet, we'll be able to uniquely identify every bird, every flight, every... I think
this one gets to a point. It's really too bad that Steve Baskoff isn't in the room, but it seems to me that the philosophy that he's edging up to, is that theoretically he knows that bird exists, and he might want to say multiple things about it, and therefore he wants those multiple things to be tied both or all to that bird, and so he's gonna I think his predilection would be to identify that with an EU.
Whether or not he would, and this would situate this discussion in the context of the semantic web. And if we start talking about how we're going to represent this in RDF, really what it comes down to is whether you're going to have a blank node representing that bird off of which you hang those qualities, or whether you're going to have a string. In both cases, you're going to have separate nodes on the graph that you may want to somehow say later in life when you discover that they're the same thing, oh, these are the same. And so if you do have an identifier to them, it seems that that will be simpler to do if you say all these identifiers refer to the same thing, rather than have to say, describe each node by its properties. So yeah, Steve advocates for this normalized, view. He wants to sort of make quite explicit that bird itself.
That node, like you said, to tie the things together.
But
he can gain information from the observation that he's making. He can take a picture of it, and you might even get a voice recording of it. I mean, sound recording. All of those things are about the same individual at a range in time.
Yeah.
And he was something. I think the.
So actually, I think you have hit your nail on, hit your head. No, hit the head of an interesting nail. So you have hit an interesting nail on the head. So there is a problem with the view I have been espousing, which is illustrated by the bird, which is, suppose we have a bird which is flying slowly, and there are 7 observers at different points, and they all observe it, and they compare notes. The times tell them it's the same bird. So in order to capture that data, you need to have a UE for that bird. But you can't satisfy criterion 3, because the bird will still be flying tomorrow. It was flying yesterday, and there's no way of associating data today, we'll assume. So that what we need is something like a semi-tentative UE, which is allowed to be used for creating a hook for the data from these 7 observations, but which is not allowed to be used to in counts for the number of birds or the number of flights, because you don't know that you're not committing double counting. But we need it, and if we have 19 observers, then A40, all right.
So how would you know it was the same bird?
Yeah, that's my point. You mean on the 7? Yeah. Oh, no, they are each watching each other and saying,
Do you still need that when it's, I mean, are you matching those people up by time?
yeah, the idea is that they're collaboratively observing.
Even if they're not, imagine that all of the birds are tagged, but you just can't see the tags. But you eventually, or you could eventually shoot all the birds.
We'll do that anyway, won't we?
There might be two ways around this. There might be 2 ways around it. Instead of giving an IOI to the bird, you give an IOI to each observing.
Yeah, that was the original proposal.
Or you do both, and the bird gets a different IOI on day 1, day 2, day 3, day 4.
And then you can resolve that one.
Yeah. And it may not, but number 3.
Because to follow your logic from earlier this morning, Bob is a different individual.
No.
5 minutes.
I'm not going down that road.
The bird is, but I have a different question for you. I've done a lot of field work in the Wind River Basin. I'm a paleontologist by training. The Wind River goes through a pass in the Owl Creek Mountains in Wyoming and becomes the Big Horn River. It's an anagenetic change, but yet it has 2 names. And if you were a taxonomist, you'd name them both the Wind River, because the Wind River has priority. It was named by, there are 2 Army expeditions that came at it in different directions. The southern one came first, and that's the Wind River. Do they both get an IUI?
No, just the one.
There's one.
Yeah.
And once you start naming segments of rivers, which people do, and then
Yes, there's segments. Segments could get different IUIs, but there's only one IUI for the river. And I'm coming to that in a minute.
Sorry.
We can choose to take a break now.
Let's take a break. We'll give the first segment of the afternoon session, the UE 1, 2, 3, 4.